morning that we have two Europeans who are staying really late up at 11 p.m. And they're going to speak to us about this topic of biomass. Biomass obviously is a very important issue right now, particularly understanding how much biomass we have in this very difficult situation where we have a disastrous phenomena with the fires. And so I believe that this topic is of very much value to the Australian community right now. Clément Albinet is going to speak to us this morning about a new biomass mission. We will have also then that followed by Laura Duncanson, who will be speaking about making sure that those measurements that we get from the biomass missions that are relevant and accurate. And Fernando is going to speak to us about the different contributions that could be made for validation or to make sure that the biomass missions are relevant. So let me start by introducing Dr. Clément Albinet from the European Space Agency. Clément is a SAR expert and currently he's working in the new biomass mission as well as Sentinel-1. Clément, can you please start your presentation then?
Thank you, Cindy. Hello, everybody. I will now share my screen. So it's even midnight right now in Italy. Okay, so I was already introduced. So I will talk to you about the ESA's biomass mission, which is called biomass, but in fact it's not doing only biomass, and it's not the only mission doing biomass. So at ESA, there are three families, let's say, of missions, as you can see here. In orange, meteorology missions, like the Meteosat, second generation, third generation. The Copernicus mission with the Sentinel-1A, 1B, Sentinel-2A, 2B, Sentinel-3, Sentinel-5P, that are kind of operational mission, so in the continuity of type of instrument that we know for a long time, and the science mission in green, as you can see on the left. And biomass is one of this mission. So that type of instrument, the green one, are new type of instrument that were not flying before, and we call them Earth Explorer, so new type of satellites. So the mission was proposed in 2005. There was a call with a lot of missions that were proposed. It was proposed as a P-band SAR, so the first P-band SAR in space. And the idea is the main goal is to provide a spatial distribution in the dynamics of forest biomass. So it was selected in 2013 by ESA as the 7th Earth Explorer mission, and is expected to be launched in 2022 if everything goes well. Why P-band? Why do we make a P-band SAR? As it has never been done before, because the P-band is a very low frequency, and as you might know, the SAR waves are penetrating inside the medium, and at P-band, it's very interesting because it penetrates a lot. And especially in tropical forests, the wave can penetrate up to the ground. So it's not only the first meters, centimeters of the canopy, but really up to the ground. And this P-band will interact with the woody vegetation elements. So as you can see on the right, you will see the branches and the trunks. And that's where the biomass of the forest is. And the forest age can be estimated with a single satellite. And the goal of the mission is to provide three types of measurements. So the forest biomass, the weight of dry matter, so in ton per hectare with a 200-meter resolution, the forest 8, the upper canopy 8, like 200-meter resolution, and the disturbance when the forest was cut or not. And a global map of these three parameters has to be provided, generated every 7 months. So to achieve that, we have a new type of instrument, which is a P-band SAR. So with this low frequency, you need a kind of geometry with a large reflector, which is 12 meter large, full polarimetric. The bandwidth is very small, 6 megahertz, because you work in a very low frequency, 50 by 50 meter resolution, and different pass, multi-pass interferometry with 3 days repeat cycles. And 2 phases of the mission. So first phase of 14 months, when you will have 7 paths over the same area, and the second phase of the mission, while every 7 months, you will have 3 passes over the different areas. So this allows to do interferometry during the first phase of the mission. I will come back to that a little bit later. So the architecture of the instrument is made with a reflector, which is part of the payload, antennas, and electronics. So the electronic will generate a pulse, electromagnetic pulse, that will go on the reflector, will propagate, will go to the earth, to the forest, will come back, will go back to the instrumentation that will compute the module and phase of the wave for the different frequencies and will digitize it. The coverage of the mission is the areas that you can see in red and yellow. So the red are the primary objectives. So we should have a coverage every 7 months. And in the yellow phase correspond to the secondary objective. So it will be best effort. We will try to make our best to acquire data on these areas. We can see also Australia on the bottom right. And as you can see over North America and Europe, there will not be, unfortunately, any acquisition due to the US space object tracking radar system. So maybe in the future, we will see that there's a compliance between the biomass instruments and this system, but today it's very unlikely. But there is not so much tropical forest over this area, so it's a little bit less important. The strategy for the coverage, as you can see on the bottom right in green, you will have 3 passes over one area. Then the satellite will roll a little bit, then 3 passes over the pink area. Then the satellite will roll a little bit and 3 passes over the blue area. Then there will be a repositioning maneuver and the cycle will continue. Then another repositioning maneuver, etc., etc. Then we can cover the whole globe with 3 passes every time, up until we achieve a global coverage. So to retrieve the biomass and the forest aid, we have 3 big methods, let's say. First, using the SAR polarimetry, which is just the intensity of the signal. So with 1 pass, we have the biomass, which is proportional. We can retrieve something. Then using different passes to have a kind of polarimetric SAR interferometry, and then the tomography, which is a 3-dimension SAR. So the SAR polarimetry, the principle is that we notice that the intensity of the signal, especially at HV polarization, was slightly proportional to the biomass. So the more trunks, the more big branches you have, the higher this cross polarization will be. So thanks to that, you can define the law and estimate the biomass. Then the second type of method is based on the SAR interferometry. So to do that, you need 2 acquisitions over the same area, but from different baselines. And you can derive, thanks to the position of the satellite, a kind of phase, position of the center of phase. So that's what was used, for example, for SRTM. It's a SAR that help to have an elevation. Except that here we are working with low frequency. So the center of phase will not be located at the surface of the elements, but inside the forest. And we noticed that with different polarization, the center of phase will be located at different elevation within the forest. Thanks to that, and using kind of model of inversion, and with this elevation of different center of phase, we are able to derive the elevation, the height of the forest. And the third technique that will be only possible during the first 14 months is using the 7 acquisition from different baseline, 7 acquisition over the same area, to be able to rebuild a kind of 3-dimension image of the forest. So 3-dimension SAR, a kind of volume. Here you have example from airborne campaign that have been performed on tropical forest. You can see in HV, HH. This is a vertical cut of this 3-dimension SAR signal. And you can see in HV that you see a little bit the branches, the canopy area of the forest, while in HH, which has a penetration is more located on the ground, center of phase more located on the ground, you will see a little bit more the ground. So using this information in 3 dimensions, the different polarization, you are able to derive an information on the volume. Here you have an example when you have horizontal cut, you can see a flux tower in metal that can be seen through the forest. Here you see different type of forest, boreal forest and tropical forest. So it allows to understand much better what are the scattering process inside the canopy. Here you can see the comparison with the LiDAR, which is in agreement, both of them in agreement, knowing that at P-band, as you can see, the vertical resolution is less good than the one of the LiDAR. A particular aspect of the biomass mission is that for the first time at ESA, we'll provide not only the data to the users, but also tools for visualization, tools for cloud computing, and a complete open algorithm and data. So the users will have the possibility to access online all the data of the mission, all the algorithm of the mission, all the in-situ measurements, and we have the possibility to change the algorithm to reprocess locally some data and to access really all the resources of the mission. This is an interesting topic that we are building at ESA in collaboration with NASA, and especially the NISAR and JEDI mission. So it's under development, but it's going very well. The forest observation system. So I put this slide to show that in the context of the biomass mission, we have activities starting to collect, harmonize a little bit the in-situ measurements in preparation of the biomass mission. So this is an activity, as you can see, with people that you know, YASA and the University of Toulouse mainly. And it's to prepare a little bit this future activity of in-situ measurements and CalVal that are needed for the biomass mission, but also for all the other mission that will fly around the same time and will observe the biomass, like the JEDI and NISAR mission. The forest scan activity, this is an activity which is under preparation, where the goal is to have in-situ measurements, but with new technologies. Not so new, but terrestrial LiDAR scanning and drones to collect forest aid and AGB with much higher precision than the usual techniques. So the objective is to collect data for 3 super sites: South America, Southeast Asia, and Africa. And this is in collaboration with the CEO's Biomass CalVal team. And the goal is also to contribute to this protocol measurements. So the team here are the team of AMAP and Matt Disney from UCL. So you see here example of measurements that have been performed in situ. This is still under negotiation. This activity should start very soon, but is not formally signed yet. And with all this information from this mission, we'll be finally able to feed the different type of user, the local user, national agency like BCS, the international agreement convention like UN Red Plus Program, FAO, and the global scientific program like the Global Carbon Project, the Global INGBP Change, and GCOS system. So as a summary, the biomass implementation, of the hardware of the satellite started in November 2013. And the critical design review took place in 2019. So we are still working for launch toward 2022. This mission will be the first P-band-SAR in space. So we'll have to face a lot of challenges, a lot of new things, because we never fly that type of instrument in space before. It's really a kind of explorer. We'll explore the Earth, explore in a new way with a new type of vision in the forest. Not only the forest, but also ice, topography, subsurface, geomorphology in desert, ionosphere, a lot of new exciting things to measure and discover. And it will have a large scientific potential that will be supported by an open and free data policy and the development of this ESA-NASA mission algorithm and analysis platform, this map tool that I presented before. I thank you for your attendance and waiting for your questions.
Thank you, Clément. I just want to say that, in fact, if you have any question to the audience, if you have any questions, could you please leave it to the last, after the last presentation, because we have 30 minutes for a discussion after the presentations. The other thing I'd like to say is if you could then also, if you like, provide your questions or comments on the chat line. I can read them out to you. And so, yeah, so there's two ways. You either can verbally ask your questions at the end of all the presentations, or you could have your questions on the chat line. Thank you. Thank you, Clément. And thanks for staying up. I know it's way past midnight. I'm really sorry about that. So Laura, are you ready for your presentation?
Yes.
All right, I'll just let you go.
Okay. All right, thank you very much for the opportunity to present. Always a pleasure presenting after Clément. So I'm Laura Duncanson. I'm an assistant professor at University of Ireland. And
sorry, excuse me. Oh. Sorry, Laura. I actually forgot. Oh my God, I'm such a bad host. I really should have introduced you. I'm sorry. So everybody, this is Professor Laura Duncanson. She's from the University of Maryland. She's an expert on forest structure and biomass, so she has interest in that area. She's actually a LiDAR expert, and she's on the NASA JEDI team. She's actually doing quite a lot of stuff in the CEOS, or for those who don't know CEOS, the CEOS is the Committee on Earth Observation Satellite. We have a working group on calibration and validation, and as part of that, we have a land product validation subgroup as well. And that subgroup actually leads a biomass validation protocol, and the person who leads it is Laura. So, so please welcome Laura.
Thank you, Cindy. Okay, yeah, so today I'm sort of splitting my presentation in two halves a little bit. So As Cindy said, I've been coordinating with John Armstrong and Matt Disney as my co-leads this biomass protocol. But the reason I got involved with this in the beginning was because I've been working with the JEDI team for several years now toward its biomass product development. And because JEDI is sort of the first in this new wave of active remote sensing satellites that will be making biomass products, the CSLPV kind of looked to us to lead the way a little bit in terms of how we're going to do our calibration and validation. So I'm going to talk a little bit about the JEDI mission, as that's the background I come from, and it's really timely right now because we're about to release our first products. And then I'll talk about the importance of doing consistent validation among many of these missions. There we go. All right, so I knew I was presenting after Clement, so I had to put up the NASA Earth Observing Fleet. So I was at NASA Goddard for a few years as well, and there's many different satellites, obviously, collecting unique data sets for Earth observation. The two highlighted in red here are the two new LiDAR instruments from NASA. So ISAT-2 and JEDI, which is the one I'll talk about a lot more. Both of these are LiDAR instruments, but with different instrument specs and science goals and application goals. So beyond just NASA, there's also a lot of other stuff being put into space that is relevant to biomass. Clement just gave a presentation on the ESA biomass mission to launch in 2022. The ones in green are already in orbit. So JEDI was just launched at the end of 2018, and ISAT-2 a few months earlier. NASA, in collaboration with the Indian Space Agency, is also launching an L-band system called NISAR in 2022. There's potentially another full waveform LiDAR coming out around the same time from MOLI, from JAXA called MOLI. And there's a tandem L concept from DLR as well. It's a really exciting time right now. We've got a lot of cool new technology in space that should be sensitive to forest structure. And I'm going to start talking about JEDI, but then I think you can already imagine that with all of this cool new data and all of these cool new products, there's going to be quite a need for coordination in order to not totally confuse our user groups. All right, so just to keep everybody awake, here's a little promo video about JEDI. So it's pronounced a la Star Wars, hence the video. It was made at NASA Goddard, so that's where all of these engineers are. Okay, so we lean pretty heavily in our communications on the whole Star Wars theme, as you can see. So "May the Force be with you" is our slogan, and this really is coming very soon. So the first 2 months of JEDI data are actually going to be publicly released on January 21st. So that's like next week. So it's a really exciting time for the mission, and quite timely. So here's a more serious video. This is the mission animation. So here we are on the International Space Station, zooming into the Japanese experimental module's exposed facility. And JEDI is essentially a refrigerator-sized box that plugs into the side of the ISS and shoots full waveform lasers down to the Earth's surface. So these are near-infrared 1064 nanometer lasers in 8 ground tracks. So it's a sampling mission. It's not making a wall-to-wall map explicitly. It's taking all of these waveform samples. So essentially the laser washes 25-meter circle area with photons, and the first photons reflect off the very top of the canopy, and the last photons reflect off the ground, making what in orange here is a full waveform. So from each of these waveform measurements, we're going to get an estimate of ground elevation, of top of canopy height, of canopy cover and leaf area index, a suite of other metrics describing the shape of the waveform, like relative height metrics, and then importantly, an estimate of above ground woody biomass. Okay, sorry about the background noise there. But yeah, so we've got all of these beautiful waveforms with a core measurement from JEDI, and we're going to have a JEDI biomass product associated with those. So as it said in the first video, JEDI, it's the first spaceborne LiDAR designed specifically to study forests. So it's akin to ISAT glass, but smaller footprints and really designed with forests in mind. We're going to have, by the end of the mission, about 10 billion cloud-free waveform observations. So this is orders of magnitude more data that than we had with glass. And as I said, the first 2 months of products are going to be released next week. So pretty exciting times. Here you can see the coverage. So because it's on the ISS, it doesn't go over the poles. So it gets up to about 52 degrees north. So it gets the full tropics. And the first 2 mission weeks of collection are shown on the left, and the first 2 months, which will be released next week, are shown on the right. So it's going to be a really rich sample of forest height and structure. But as I said, it's a sample mission. And so thinking back to that early slide, we also have ISAT-2 in orbit now. So we've got JEDI collecting all of these wonderful waveforms, and we're making estimates of biomass with those. And then we have ISAT-2. Here's 2 years of simulated ISAT-2 track coverage in blue and JEDI coverage in green. So you can see that there's a spatial complementarity to these data sets. If you're just talking about spatial coverage alone, they're both LiDAR samples. So if you combine these 2 LiDAR samples together, you get a lot more LiDAR data. ISAT-2, as you could guess from the name, it's not designed for forest structure. It's really designed for ice and solid earth, but there is a vegetation height product already out there, and we're looking to explore its utility for biomass estimation. And it looks like ISAT-2 is actually really good for biomass in areas that aren't totally dense closed canopies. So in the boreal or in woodland savanna type areas, it's going to be a really nice additional data stream. So now we have JEDI and ISAT-2 already on orbit, but with all of the other stuff to come, we're starting to play around with different biomass fusion algorithms, right? So JEDI plus ISAT-2 plus NISAR, for example, with L-band backscatter, add in the P-band from biomass, maybe Landsat, maybe TandemX. There are all of these different ways to combine all of these exciting new measurements together to get reduced errors, higher resolution maps, etc. So it's a world of new remote sensing science possibilities, which is quite exciting. But when you think about all of those potential combinations, you can imagine that we're moving from a time of having essentially no high quality global biomass maps to having not only the official mission products, but every PhD student in Google Earth Engine can make their own global biomass map, which is awesome. But it's potentially going to cause a little bit of chaos for non-remote sensing specialists who just want to use a good biomass map for their forest management or science application. So we're going to have, essentially going from maybe 3 maps to potentially hundreds of maps, and we have to help guide that user community toward knowing which biomass products are going to be the most useful for their various applications, right? So that's really where the CIOS biomass protocol comes in. Because JEDI went first, that's John Armstrong and I are both on the JEDI team, and Matt Disney, who's a TLS expert. The 3 of us have been leading this, but with a really large group of contributors, both as the chapter leads who are highlighted on this slide, and chapter co-authors and editors and reviewers and whatnot. So the general idea is that we're writing a good practice guidebook for how to not only build your biomass products, keeping in mind error propagation and reporting, but also how to do validation of those products over some user-defined area of interest, be it global or continental or tropical or something like that. So we want to help tell users which subset of all of these upcoming biomass products will be the most useful for them, and also try and get some consistency amongst map producers with respect to how we're going to be reporting accuracies. Like even things like using the same words for accuracy and error is a bit of a challenge to get some community consensus on. So in a nutshell, what we've written so far, and we started this in 2017, so it's been quite an effort. It's about a 200-page document. And we're just kind of putting the last bells and whistles on it before we go through a 1-month review process in February. But we've got recommendations for how to put in reference data sets. So obviously for validation, we need reference data sets. So how to account for allometric model error, measurement error, How do you do terrestrial laser scanning with spaceborne CalVal in mind, which Clément spoke to a little bit with the forest scan things. We have separate chapters on all of those. And then we're also highly recommending the use of airborne LiDAR maps here. So taking those high quality training forest plot data sets and then using airborne LiDAR to scale it to the right size and shape to match your remote sensing spaceborne biomass pixel. So we can't just compare small plots to large pixels. We've got to get the spatial resolution matched up. There's whole chapters on error propagation and how there's a chapter on recommending how users who want to do their own validation, what to do and importantly, what not to do. So don't take those small, poorly geolocated field plots and try to validate a 1 kilometer biomass product. It's essentially a meaningless exercise to do that. So we've got a very hands-on guide of how to go through a validation if you have your own reference data and you want to do that comparison. So I can't go into all the details of the protocol because there's a lot in there, but we are also highlighting a bunch of knowledge gaps. So the protocol isn't, the sort of be all and end all of biomass. There is a lot that we still have to learn as a community. So we're sort of highlighting some of those experiments that we need to do. And there are also a lot of data gaps, which I'll get into in a second. But the sort of overall concept of the biomass protocol is take the highest quality field measurements possible, preferably with terrestrial laser scanning or propagating error properly through your allometric model. Train local airborne LiDAR datasets to make airborne LiDAR biomass maps that can be scaled to multiple resolutions to match whatever resolutions the biomass products you want to validate are. And then report the accuracies over some domain of interest using a set of biomass supersites that have these high quality field and airborne LiDAR datasets, and then propagate error throughout. So that's the sort of general concept of what we're proposing in that protocol. Of course, this is just a white paper, so it's this big protocol, but we want to bring it to life. We want people to actually take this and use it. Otherwise, we've kind of wasted our time. So we see to do this, we really need two things. We need updated reference data sets. So without high quality data, we can't do the validation, right, obviously. And we also need some open, transparent tools to help users do this themselves, or even just to help coordinate consistency amongst the map producers so that we can all compare kind of apples to apples when we have all these products. We're exploring, Clément presented the ESA-NASA multi-mission algorithm and analysis platform that he and I both work on. So we're exploring trying to use that for some of the validation tool side of things. So I will focus the next couple of slides on the updated reference data sets. So, and this is going to flow into Fernando's talk as well. But we're obviously without reference data, we can't do the validation, right? So we've been working amongst sort of the active remote sensing mission teams on trying to pull together as much quality reference data as already exists and make a set of recommended biomass super sites. So here we have in red where we have existing field and LiDAR data, and this is the stuff that JEDI's used to train its biomass algorithms. In blue, there's a bunch of sites that have planned field and LiDAR data that they either aren't available yet because of data restrictions or they haven't been collected yet. And then Clément mentioned the FOSS, which are shown in turquoise, and these are field plots that are high quality field plots that don't have the airborne LiDAR component. So, oh, and I should highlight here that Australia has really played a leadership role in a lot of this CalVal through TURN and other networks. So that's been kind of invaluable, and I think that yeah, the sort of collaboration of networks across the globe is a really powerful thing, and we just need to coordinate a little bit better to make sure we all have the same types of measurements and open data policies. So if you take a subset of those different plots that I just showed, this is with our protocol, we're submitting this set of biomass super sites that are essentially sites that have the airborne LiDAR and field components or could have them. And we think will serve validation purposes for all of the upcoming biomass products. So you can do things like scale to different resolutions and there's accessibility and all that. The problem here though is that this is not a funded activity. So we can say, here's the recommended biomass super sites, and nobody might measure there, right? So we have to make sure that we have this sort of time series of long-term plot recensuses and multi-date airborne LiDAR to make sure that these reference points are current, and that obviously takes a lot of effort and funding. So that's really where we see potential future collaboration, is trying to consistently fundraise and then consistently remeasure these biomass supersite plots. Okay, so then just to conclude, it is really an exciting time to be in this field. We're in the sort of golden age of active remote sensing. We've got all of these new exciting data streams coming online, JEDI and biomass and others. But we really, we have this sort of this luxury of data wealth, but with it comes this responsibility to make sure that we're trying to give users something useful and not just drowning them in data, right? So we've got to do transparent and consistent validation, and that's a really critical exercise. Obviously, that requires a lot of funding for plot recensus, and that's one of the areas that that we're sort of trying to figure out right now, is how much of this can NASA fund versus ESA versus JAXA, and if, you know, if we can kind of split the world by agency and all the agencies commit some amount of funding, then hopefully we can get a large way to covering those biomass super sites. And we really do see CIOS as this natural pathway toward continued biomass agency collaboration. It's kind of the perfect role for CIOS, and so we imagine that even after the protocol is published, that we'll continue using the CIOS umbrella for a lot of this coordinated CalVal work. Okay, so that's all I had, and you can follow JEDI for mission updates and things on Twitter at JEDI Nights, and there's my Twitter handle as well. Thank you.
Thank you, Laura. That was very interesting. We will now move on to our next presenter, who's Fernando. Fernando, are you ready to take the, I think, Laura, I think you might have to unshare your screen.
Hello.
Hello, Fernando.
Do you want to introduce
yes,
myself?
please. Yes. Okay, so way past midnight for you, like 40 minutes past midnight. I'm really sorry. So Fernando, so we have the next speaker we have is Professor Fernando Camacho. And Fernando is an expert in biophysical measurements from Earth observation data. He leads the Earth observation laboratory at the University of Valencia. And for me, he actually does a wonderful job as the CIOS WDCV Land Product Validation Chair. And so Fernando today will be talking about an initiative which he led related to evaluation of the different super sites across the world. And how they are relevant for biomass validation. Thank you, Fernando.
Thank you. Good morning, everyone, and thank you, Cindy, for the invitation to this webinar. And well, as you say, my talk is about the land product validation supersite. This concept is not only for biomass, but they are also relevant for biomass validation. So this work has been conducted in the framework of the land product validation subgroup of the CIOS working group on CalVal. So my first slide is to introduce a little bit more this land product validation subgroup, which, as you can see here, is one of the working group of the calibration and validation working group of the CIOS. And within the LPV, we have 10 focus areas. Most of them are related to terrestrial climate essential variables like FFR, fires or land cover, soil moisture, etc. And among them, there is the above ground biomass. As you know already, Laura leads this focus area group. And our objectives, as you can see here, first of all, to foster and coordinate quantitative validation of global products derived from remotely sensed data, to increase the quality and efficiency of the product validation by developing international standards and protocols, as Laura explained, for the above ground biomass. We have also protocols already published for leaf area index, surface temperature, and albedo. We are working also in improving the quality of the reference data set, which is a quite important area, including the fiducial reference identification of sites or super sites. And also we provide feedbacks to international bodies like GECOS. So linking to the conclusions of the Laura talk, validation is a very, very important task before delivering a product to the users. So basically, we should have in mind that validation aims to answer a simple question: is how good is an Earth observation data set? Its accuracy, is precise, is stable, etc., and to determine the fitness for purpose of the different user application. And still, the access to fiducial ground reference is a key component of this validation process. It's not the only way, but it's a key component. And for that, as we are delivering global products, we need also global network of validation sites that should be established in order to maximize the return of investment of a satellite mission by providing this uncertainty attached to the product in order to make the proper use of this information. So in the land product validation group, we adopted a number of core sites for validation, but at the early MODIS era, let's say around 2000. So most of these sites are not longer active, or they does not allow detailed characterization of the site. So we need to undertook a re-evaluation of the site. This was an action of the sales work plan of 3 years ago. So the objective was to evaluate well-characterized sites with data continuity prospect for the validation, and should allow testing different products, algorithms, and validation strategies, also including the use of detailed radiated transfer models. We also consider several actions of the recently implementation plan of the GCOS. And for instance, some of these actions are that the site should serve multiple product validation rather than only one variable, improve the access to ground data with well-defined protocols, or also one action make specific reference to the biomass and improving the access to the forest inventories data. So at the end, we came with a LPV super site definition. This is a super detailed site in terms of three-dimensional structure and biogeophysical variables that should be collected, of course, following well-established protocols, and be useful for validation of different satellite line products, and also for testing algorithms with radiated transfer modeling approaches. The site should be, of course, active with long-term operation and supported by appropriate funding and infrastructural capacity. This is sometimes a problem, the lack of funding, and is desirable to be supported by airborne LiDAR and hyperspectral acquisition. So we evaluated several networks currently operational, like the Australian super site network that most of you should be aware of this. These are the location of the 10 super sites. Some of them contains more than one location or several plots. And a particularity of this super site network is that provide calibration and validation data for remote sensing products. It's of course open access and well documented in protocols. So there is a lot of information in this Australian super site networks. As you can see here, there are 4 portals, each of one containing different information. And for house cover, there are information related to the vegetation structural properties and biomass. You can see here example of terrestrial laser scan for individual 3 points and also intensity image for the Himalayan cedar forest, which was obtained both with TLS data. And there are also biomass plot libraries available over quite a large number of points in Australia. So as you can see here in this summary slide, we can obtain information about radiation, moisture, phenology, LAI. We have information on structural, TLS, airborne data protocols, and free data access. So this makes very suitable the Australian supersite networks for our purpose. We also evaluated the National Ecological Observatory Network with a strategically located site across US. 20 core sites are fixed and collect data for a minimum of 30 years. So this is a long-term operation. And also it is important to say that there are a coordination of the field data with high resolution airborne campaign or airborne data. So there are two types of science teams. Those providing the field data, as you can see, I'm highlight the variables that are of more interest for our land product validation, and the airborne observing platform science team provides also a LiDAR point cloud information and hyperspectral data and products. However, there is missing detailed three-dimensional structure. For instance, the terrestrial LiDAR is not available, so the usefulness of this neon site for biomass is needed additional data sets. We evaluated the ICOS, which is over Europe. There is around 71 stations with open access. And you can see here that there is also a lot of information, albedo, LAI, FFA, phenology, etc., including the 3 diameter and above ground biomass. All of these are well documented with protocol. All of this is free information, but there is a lack also of detailed vegetation structure, TLS data, or is not supported by airborne data. I know that even if this is not official ICOS data set, but there are some initiatives to collect TLS over some ICOS. So it could be also useful. And of course, the above ground biomass information is of very relevant for biomass validation. And we also evaluated additional network proposed by our LPB members, like the Environnet Tropic Dry network of site, mostly over America, in which there are inventories, TLS, airborne LiDAR, and much more information on the forest structure. So at the end, we came with about 150 potential sites. And one of the very important requirements is the spatial representativeness of the site, because we have different spatial resolution of the satellite product to be validated. And sometimes the typical site of the size is 1 hectare, and sometimes there are measuring in the tower. So we filter visually homogeneous site at 1 per 1 kilometer at minimum, and then the site were ranked based on how many variables could be validated, if the structural information is available or not, if there is airborne LiDAR or hyperspectral data, etc. So at the end, the version 1 of the land product validation sales Carval site includes 55 super sites located mostly over US, Europe, and Australia. This is how it looks, and examples of the super site with Google Earth. And I would like also to show more details, 2 examples. One in Australia is Tambaramba, is one of the super sites that I think, unfortunately, have been affected by the recent fires in Australia. This image and information is courtesy of Will Woodgate, and you can see him in the picture. And this is a very good example of what we are looking for when we talk on supersite. So we are looking for information on radiation and meteorological information, etc., that comes from a tower or zeta flux in that case. Supersite over 1 hectare information related with biophysical, biodiversity, structural, landscape, part network, etc., TLS, scan. So detailed information on the structure, and also over a larger area, airborne data. In this particular case, hyperspectral and thermal scanners are also available. And this is an example of the three-dimensional model that can be very useful for accurate estimation of a biomass and for biomass validation, but not only. And some example of the hyperspectral camera 3 times of the day, very useful. For instance, this is a site that was considered for flex calval activities, and also for eco-stress. And this is an example of the thermal image at 3 times of the day. And another super site is the Wytham Woods in the United Kingdom. This semi-natural woodland is managed research forest with more than 75 years of ecological monitoring. So it's not a very large site, but it has a lot of history. As an example of the dataset that can be obtained in this site is FFR. There is a network of 31 nodes, as well as other information like leaf area index, chlorophyll, surface reflectance, etc. And also they have a very detailed three-dimensional model. This is the sampling that they performed, conducted with the TLS, 176 scans in an area of 6 hectares. And this data allows to build the tree model, and also to reconstruct or to construct a three-dimensional model of the canopy. Of course, this site is very useful for biomass, and in fact is one of the biomass super sites multi-mission, as Laura told previously. So in conclusions, LPB recently undertook evaluation and selection of Earth observation land validation supersites. 55 are selected. Canopy structure information is available about ground biomass, TLS, and airborne LiDAR, but it is not homogeneous across sites. So some of these sites are very relevant for biomass validation. Some of them are already included in the multi-mission biomass super site, and others could be if some additional effort in the ground data collection, for instance, could be performed or funded. So the establishment of Earth observation validation super site, which is quite critical for validation purposes, is still an ongoing activity. For instance, in Europe, we have now 2 activities, one of the European Spatial Agency and other from the European Commission in this direction. And we need to improve several areas. For instance, the spatial coverage, as you see, is not global. The uncertainty characterization is not always well specified. So we need to also agree on protocols for uncertainty of ground data sets. And at the end, we would like to improve the data interoperability among the different networks of supersite to build a global supersite network for validation of different land products derived from remote sensing. So I think this concludes my presentation. Thank you for your attention, and you can see more about the supersite or download the coordinates and the information available in each site, etc., in our webpage. So thank you.
Thank you, Fernando. That was very useful. So we now have concluded all 3 presentations, and so we would like to open up the floor to discussion or questions. I see we already have at least two questions. So the first question was from Ashka Chabra. If you'd like to speak up, or if you'd like me to read the questions out. The first question is actually from for Clément. It relates to P-band in biomass mission. What biomass estimate in is the signal likely to saturate?
So I imagine, yes, can you hear me?
Yes.
So thank you for your question. Here I imagine that you're talking about the polarimetry, so just the intensity of a signal. And we noticed that we could have saturation after 500 ton or megagram, if you count in megagram per hectare. But this is only if you use the polarimetric, so just the power of one polarization. Because while using the tomography or the pulsar, you can have different phenomenon according to how scatters are organized, and maybe you could go up to 600, 700 megagram per hectare. These are the first results observed with airborne campaign P-band SAR data.
Ashkar, did that answer your question, or do you have any others to add? I believe so. So he says, thank you. So the second question that is on the chat line right now is from Andrew Skidmore. And this question is for Fernando. Are all super sites data free and openly available?
Yes, the general answer is yes. This was the idea to look for sites with open data, but for some sites, data could be should be requested, and so it's not directly available on the portal. For instance, in ICOS, it depends of the level of processing. So there is some particularities, but in principle, all data is free and available. If not directly, indirectly through the contact of the site. And you can see all this information in the sheet that you can find in our webpage of SuperSite.
Okay, Andrew, there is actually an answer from Stuart. If you have read on the chat line, Stuart says that yes, in terms of Australian turn sites, they're all available on the SuperSite network, as well as the TLS data. I think some TLS data needs to be requested, if I understood, well, just from my knowledge. I guess, yeah, I can add a little bit to that answer, because one of the things, by the way, if I didn't actually say this, and why I'm super interested in this initiative is I chair the CIOS working group on calibration and validation, and so all these things are part of the different babies that I have. So basically, part of the LPV SuperSite, what we hope is to allow people to access the data and also get them, additionally, I think Fernando talked about this, interoperable, and I think Laura also said that, you know, they're all consistent, that people can get to. The other question that I see on the chat line is from Zhang Shu, and this is for Clément again, regarding the biomass mission. How long will it take for 7 data stack acquisition?
So between 2 consecutive pass over the same area, you have 3 days. So for the stack, you will pass once, then 3 days later, a second time, 3 days later, a third time, etc. So you need 18 days to achieve the 7 pass over one area. Then you will do 7 pass over the other area, 7 pass over the area, etc. So you have 3 days between different areas. So 18 days for the stack, but you need 14 months to cover the whole globe. And during the following phases of the mission, interferometric phase, it's the same. You have 3 days between 2 consecutive passes over the same area, but you have only 3 passes, so you need only 6 days and 7 months to cover the whole globe.
So Zhengshu followed up that question with how about temporal decorrelation?
So the temporal decorrelation was so on 6 days you have almost no decorrelation, and for the 7 pass at 18 days we measured with airborne campaign and with in situ SAR P-band SAR system, like the TROPISCAT of the AFRISCAT mission, that was a SAR system every 10 minutes making acquisition. We noticed that it was after 20 days that there was a decorrelation going below 0.8, for the decorrelation. So you have enough correlation to be able to do interferometry and even tomography using all this stack.
Okay, thank you.
There's a question in between.
There's a question in between from Kate Fuller. For you again, Clément, you're very popular. Would you mind talking a little more about the US-based objects tracking radar and why that prevents data collection of P-band SAR data in North America?
So this is in fact the anti-nuclear missile shield against, I imagine, Russia, which is built all over the US and with one station in England. England has always been close to the US. And the problem is that this system operates at P-band, so at the same frequency as the P-band SAR. And for the P-band, when the P-band one was opened by the ITU in 2004, the International Telecommunication I don't remember what it stands for, Union, certainly. And the P-band for space observation is not scientific observation is not the priority. So if the military people are using the P-band, we should not aim it. So we have to turn off the instrument. Otherwise, we would provoke some interference in the system and they would provoke interferences in our system. There were ideas of campaign, doing airborne campaign, especially with NASA, that has a P-band SAR airborne instrument to fly in collaboration with Department of Defense, American Department of Defense. But I have to say the Department of Defense, the Army in general, American Army, was not very willing to collaborate even with NASA. So finally, there's never been that type of campaign. And today, we imagine the worst case, that we will not have any data over North America and over Europe. But maybe we are very pessimistic and we'll be able still to acquire locally some data. We will see.
So there's thanks, Clément. There's a question now for Laura from Tim Danaher. When do you expect the good practice guide to be available to users?
Excellent question. Yeah, so we're actually, Cindy, this might be back to you. Can you remind me, when are the CIOS plenary meetings or SIT meetings in March?
The SIT meeting in March is 23rd to the 26th of March.
Okay, so that's probably going to be the answer. So we're kind of finishing the edits and things. Then we're going through this sort of 1 month review period we've had a bunch of people sort of volunteer to review it. And the goal was to get it endorsed at that next CIOS higher level meeting, along with our biomass supersite list. So that'll probably, hopefully, as long as the CIOS higher ups don't have any issue with it, we'll then publicly release it following that meeting. So end of March, I guess.
Yep, so generally it's a procedural thing that we get endorsement and it should be pretty straightforward. And you guys should be able to get it, very soon afterwards. And we do, just to let you know, we actually also do have a CIOS website, and it's called the CalVal Calibration and Validation Portal. I can send information to everybody, and that's where you get this protocol will be published there, as well as other places that Laura would put it at. But generally, all these information together with other protocols that Land Product Validation and Working Group CalVal does will be available there. So would they, I'm just looking to see whether we have any, okay, so there's a question from Wendy. Will that release of good practice guide be linked to the EOA site as an interested government end user? Well, I guess we will, I mean, Wendy, you are also part of the committee, but I guess we should ask Larissa and Stuart, but I believe that it is possible for us to put those kind of documentations on the EOA website.
Hi, Cindy, it's Stuart. Hi, everyone. I do think probably the easier way is to make sure that the resources part of the EOA website points to the relevant part of the CIOS website. We are going through a major reorganisation of the Earth Observation Australia website to make it more usable and user-friendly. So links to these good practice guides across a range of different sensors and applications are critical. So it's a really good suggestion.
Yes, and we definitely can give you the link to our CalVal portal as well. Were there any more? Okay. Zheng Shu asked whether he can have another question to Clement. So he asked about the mission products, data processing level, data volume, and data distribution.
So this is still under, say, definition, but the product should be standard product. So the level 1A, which is SLC, single loop complex data in the geometry of the sensor. Level 1B, which is projected on the ground. Level 1C, which is stacked co-registration of the different passes over the same area. And then what we call the level 2 could be, might be on demand on that type of map platform. And it should be the level 3 that should be distributed after every global coverage, maybe 1 month, 2 months later, because we need to process everything. Global map. So from this platform, there will be the possibility to download the data, like always, to visualize them directly, and to work on this data and to put together biomass, NISAR, and GDI data. That's a little bit the idea. But it's still under definition. We're still adjusting a little bit the parameters and trying to understand how the thing should be done.
Thank you. Was there more questions? No. Okay. Well, so maybe I should ask a question, and this is for Fernando and Laura. So you identified knowledge gaps, you identified the need for collaboration. So we have a community of Earth observation scientists here in Australia who are very, very active and I guess have a lot of expertise. We have the super sites. How do you think you know, we can get actively involved, or people in Earth observation Australia can get actively involved, and how, you know, what mechanisms, how do they do it, what's the forum, etc.
Fernando, did you want to, or do you want me to respond to that? I think you're muted still, so I'm gonna, well, so I guess it's to me. Yeah, I mean, certainly for the, right, there's this funding question, right? So if possible, once we have the, or even now, if you think that there are some potential funding streams for either putting in new biomass super sites, and I imagine this would also work for the LPV-wide super sites. If you think that there is a site that isn't currently in there that has good data, or you are thinking about a proposal to put in a site, or especially do a recensus of an existing site, that's fantastic for us, because we've sort of been guided. Doing the field component is sort of outside of NASA's mandate and sort of agency goal, except for specific CalVal for individual missions. So this sort of longer term biomass mission-wide kind of concept, I don't think any one space agency is going to tackle it. So if, like, to the degree possible, any funding pools on the Australian side that could be tapped to kind of keep all of the wonderful Turn and other sites alive and updated and kind of remeasured. There might be slight tweaks to kind of make it consistent with what we're recommending in the other sites globally, but anything that could be done to keep that updated and open and publicly accessible is a huge deal. So
Fantastic.
keep doing that, I guess. Fernando, I don't know if you have anything to add to that.
Well, yes. Well, I would like just to say that in the LPV, as well as in the working group of calibration and validation in the cells, we are some kind of databases that are useful for the validation. So anyone that can provide data to populate this database is very welcome. So first step is just to contact us and then talk about which kind of data could you provide, or do you think is useful for the CEOs community. So we have experts to evaluate your data and to say, okay, this is quality, best quality, or is useful but doesn't match, let's say, the criteria of homogeneity or upscaling or whatever. So in that way, at the end, we provide, let's say, sales working group CalVal certified data sets for the validation of the different missions. So the collaboration in terms of the ground data exchange is very important. And so you can also subscribe to our list server and keep in contact with the different groups of the land product validation. So this is a way to stay in contact. And also maybe with the next sales workshop that will be held in Canberra. If you have the opportunity to attend and to participate, then we can discuss more on this collaboration. But I think it's really important. And I have one question for you, Laura, related to this collaboration, because I have also very interested in the LAI product. You know, I'm working on that since early 2000s, and now it seems like my moment 20 years ago, but for biomass. So we still need a lot of data for validation of leaf area index and FFR. JEDI is providing an LAI product?
Yeah. Yeah, it's the, so there's the level 2A is forest height and height metrics, and then level 2B is LAI and canopy cover. Okay,
so this, and how do you plan to validate? There is also LAI data in your biomass super site, because it's quite related. And one thing that I would like to achieve, I don't know if it would be possible or not, but is try to also involve more the people working on biomass on those LPV super sites, because I think that with a little more effort, these sites could be very useful for validation of all the emissions, particularly LAI or FPAR.
Yeah, I totally agree with that. I should also say, yeah, we've been saying these are bio. Sorry.
Maybe are you collecting LAI as well, or?
Yeah, so when we're talking about these biomass super sites, you could almost think of them as forest structure super sites, because of course, if you have the terrestrial laser scanning and the airborne LiDAR data set, that will validate all of the JEDI products, right? So, but we just sort of
canopy cover LAI.
Yeah, exactly, tree height. So maybe they would, but we don't really want to rebrand at this point because we're sort of in this woody biomass, forest woody biomass domain. But all of the biomass super sites would be completely useful for validating the lower level products as well. Biomass, I would say, is more challenging than the lower level products because you're sort of adding a model to get it from those quasi biophysical measurements. Like forest height is essentially a measurement from JEDI, and then we're applying some statistical model to estimate biomass. So it's like biomass is more challenging, I'd say, to validate than the other ones, but the other ones certainly can be validated with the same sites.
Okay, great.
Fantastic. Fernando, and everybody actually on the, who are still left on the webinar, one of the things Fernando said, which actually clicked that I actually should announce, is that in March 2nd, on March 2nd to 6th, if for those people who are deeply interested in these topics, particularly the super sites and the validation of biomass, we do have a CSWGCV LPV workshop, and which will be discussing in more depth these topics. I will send it out, the information to everybody. Possibly the best avenue would be through the EOA website, and we will put that information and the program available to everybody. What do I say? Everybody's welcome to join, and yeah, you'd find more information there. So I go to the next question from Flora on the biomass mission. Is there any connections with the GFOI work? Clément.
Of course, they are. The biomass mission was justified. The selection of the mission was justified because there were user and activity that needed information, and GFOI is one of these activity. Today, we are in a phase where we're building instruments, building the processing on the ground. So it's a very light connection, let's say. But the Center for Earth Observation, where I'm working, of ESA, is based in Rome, close to FAO. So in the future, when we'll be close, a little bit closer to the launch, and when we'll have especially the first data, we'll have stronger connections, let's say.
Flora, did that answer your question? She says merci. Okay, would there be any more questions from everybody else? Anybody else has any burning questions? If not, I will try and wrap up and let these people go to, these nice people in Europe go to bed. Poor thing. Yeah, and I thank all the presenters very, very much for their very nice presentation. I see that there has been quite a lot of thank yous also on the chat line, and compliments on the presentation. So thank you very much. I think I need to share my screen. And there was an announcement right at the end that we're supposed, okay. So there is an announcement, hang on, I don't know why it actually didn't go all the way. Sorry, excuse me, I just try and get to the announcement. So as you know, we do have a few announcements at the end. This is a forum advancing of observation Australia. This is a conference that we will be having from the 28th of September to the 2nd of October. So please save the date for it. It will be held in Brisbane at the Brisbane Convention and Exhibition Centre. I was thinking that perhaps if there was sufficient interest, perhaps they might be a possibility to also get together a biomass forum. I see that there's 2 more chats, so I'll just see whether people wanted to ask more questions. Where is it now? I can't seem to. Okay, so basically it's all. Thank you to everybody. So that's the end of our webinar. And if I will, as I say, send out information about the workshop to everybody through the EOA website. Thank you very much.
Thank you.
Thank you, Cindy,
Thank you.
and thank you, Larissa, for the organization.